Hello, and welcome to our discussion on repeated measures ANOVA in preparation for our final exam. Dr. Leung here is wondering which test is more perfect, the repeated measures ANOVA or the ANOVA. I have done some research and found that the repeated measures ANOVA is the king, and it beats ANOVA. For these reasons, these are the advantages that repeated measures ANOVA has over ANOVA. So unlike ANOVA, repeated measures ANOVA examines the changes in each single subject's scores over time under different conditions or on related variables. Therefore, repeated measures ANOVA controls for errors due to differences between subjects. So this is really exciting because you can actually see the difference between each case by case versus just seeing the difference between the groups as in ANOVA. And this builds on number two builds on number one. By the repeated measures ANOVA being able to control for errors due to between subject differences, it is able to extract one or more sources of variation. So, for instance, within subjects, variation. Number three, by explaining more sources of variation, then it therefore reduces the error variances. And it leads to number four, that it increases the power of the repeated measures ANOVA in testing the null hypothesis. Therefore, we can with more certainty say that we are rejecting the null hypothesis when it is false. So in the repeated measures ANOVA, you have your within subjects, or you can do between subjects, the mix between subjects, actually. This one should say mix between within subjects. So the within subjects, you can repeat a measure ANOVA. You talk about different occasions. You can measure someone on time 1, and then measure them again on time 2, and then measure them again on time 3. And then here you're just seeing the difference between the 3 different times. However, here we're mixing it up. We're actually trying to see the difference between these groups, males and females on time 1, males and females on time 2, and then males and females on time 3. Assumptions. I made the mistake of thinking the manager of a Christian bookstore wouldn't have a gun. So this guy did not check his assumptions. He just jumped in. But that's not what we're going to do. We're going to check our assumptions before we do repeated measures ANOVA, just like we do for any other test. So the repeated measures ANOVA assumptions are pretty much like the ANOVA and the ANCOVAs. This is a ANOVA only because there's, you'll see, I'm using not the ANCOVA, repeated measures ANOVA assumptions. So sample representativeness, obviously what this means is that we will be generalizing back to the population that we're sampling. So we got a random sample from a population, let's say of college students or high school students, and we're going to use these results to generalize back to high school students, not to seniors. Level of measurement, what this is talking about is that the dependent variables should be continuous and they should be measured at an interval level or higher. The sample size, we should have 30 subjects or more. And because we're looking at within subject scores, every single score should be completed. Normal distribution, the dependent variable should, under every condition or at every time, the dependent variables should be normally distributed. And we check this by looking at the skewness, the kurtosis, the histograms, PP plots. And the assumption of sphericity, and the reason why that has a star by it is because this is different from ANOVA. And what this is saying is like the variances between the differences between time 1 and time 2 versus time 1 and time 3 versus time 2 and time 3. If we were to subtract those scores from each other and check those variances, they should all be similar to each other. And that's what assumption of sphericity is. Now, compound symmetry is very closely related to sphericity. It's very hard to measure. But what that is saying is not only do the variances of all the pairs need to be equal, but the covariance of all the pairs of different scores should be similar. So the covariance between time 1 and time 2, time 1 and time 3, and time 2 and time 3 should also be similar. The range of scores, and this makes a lot of sense, is that the measures for all repeated measures should have equal possible ranges. So the same minimum and maximum scores. So we shouldn't be comparing across two different, like the highest I can make on one is 70, the highest I can make on another is 50. That really wouldn't make sense. The recommendation from Abu is that if they are different, they should be standardized so that we can actually really see what we're comparing. And then if we have the mix within repeated measures and ANOVA, we need to be checking for the normality of distribution, and that's all the dependent variables should be normal for each level of the independent variable. Homogeneity of variances, the variances on all measures of dependent variables should be equal across all groups. And then the homogeneity of variance covariance matrices, which we are already very familiar with, and that is that the covariance matrices on all measures of the dependent variable should be equal across all levels of the independent variable. But remember that this assumption is only needed if the groups have unequal sample sizes. Again, remember we check boxes M to see if this is right, and we look at the P. The P should be larger than 0.001. Now, I wanted to go back to assumption of sphericity, that we check this by looking at Mauchly's W, and the P should be greater than 0.05 for this assumption to be met. So that's the test that we use for assumption of sphericity.